Lecture number 6, Kinetic Theory of Gases and Radiation. Today's lecture we are going to see what is meant by perfectly black body. Perfectly black body. Here, a body which absorbs all radiations incident on it is called as perfectly black body. And for it, QA is equal to Q and A is equal to 1. Now, here you see, no perfectly black body is in exist. Lamp black, and platinum black. Lamp black and platinum black, they are treated as perfectly black body. Now, here we consider the construction of the perfectly black body. Suppose we consider the diagram. Perfectly black body, it consists of a double walled, here double walled hollow metallic sphere, here this is the double walled hollow metallic sphere having one aperture, and in front of aperture we consider there is a conical section. This is the conical section. Here this is the double walled hollow metallic sphere and having one aperture, and in front of aperture there is a conical section. Now here you consider inner side of this spherical inner sphere is coated with lamp black or platinum black, like this. Inner side is coated with lamp black or platinum black. This is the double walled, I will write here, double walled. Now here this is the silver polished surface, This one is the conical section, Now this is the, we consider this one, surface coated with lamp black, and we consider here this is the evacuated space, and we consider this one is the aperture. These are the some sections of this sphere. Now whenever heat radiation enters into this sphere, then from this conical section it reflects. It suffers multiple reflections like this. And during each reflection 98 or 99% of heat is absorbed, and finally all heat is absorbed. This is the construction of perfectly black body. Now we consider next article here. Emissive power. The quantity of radiant energy emitted per unit time, per unit surface area of a body at a given temperature is called as emissive power, E. at that temperature. I repeat again, the quantity of radiant energy emitted per unit time, per unit surface area of a body at a given temperature is called as emissive power E at that temperature. Now we'll consider next definition. Emissivity or coefficient of emission. Emissivity or coefficient of emission denoted by small e. See here, suppose you consider emissive power of a body is E. I will write here. E is emissive power of a body, and EB, E suffix B, emissive power of perfectly black body. Now, if we take this ratio E upon EB, then this ratio we call it as small e, and this is the coefficient of emission. That means coefficient of emission is the ratio of emissive power of a body to the emissive power of perfectly black body. This is all about the emissive power, emissivity or coefficient of emission. Now we consider next article here. Prevost's theory of heat exchanges. Prevost's theory of heat exchanges when hot body is placed in cooler surrounding. Hot body placed in cooler surrounding. Then heat flows from hot body to cooler surrounding. Now we consider the next case. Cooler body is placed in hot surrounding. Cooler body is placed in hot surrounding. Then heat flows from hot surrounding to body. Now according to Prevost's theory, here we consider first, every body radiates heat at all temperatures except at absolute zero temperature. This is the first point. Every body radiates heat at all temperatures except at absolute zero temperature. Second point, the radiant energy emitted per unit time depends only on its absolute temperature. These are the 2 points, and does not depend on temperature of surrounding. Two points, everybody radiates heat at all temperatures except at absolute zero temperature. And second point, radiant energy emitted per unit time depends only on its absolute temperature and does not depend on temperature of surrounding. Here, that means exchange of heat is in both directions. That is from body to surrounding and from surrounding to body. But rates are different. Suppose I will write here. Suppose hot body, cool surrounding. Hot body, cool surrounding. Now cool body, hot surrounding. hot surrounding, cool body, and cool surrounding. Here hot body, that means hot body to cool surrounding, cool body to hot surrounding, hot surrounding to cool body, and cool surrounding to hot body. Only here rates are different. Here you see hot body to cool surrounding, I will write here high rate, and cool body to hot surrounding low rate. Again hot surrounding to cool body high rate, and cool surrounding to hot body low rate. This is all about the reverse theory of heat exchanges. Now we can see the next article. Next article. Kirchhoff's law. Kirchhoff's law. First we will see statement. Kirchhoff's law statement. At a given temperature, coefficient of absorption is equal to coefficient of emission. That means I will write mathematically small a is equal to small e. This is the statement that at a given temperature, coefficient of absorption is equal to coefficient of emission. Now we will write here, but small e is equal to E upon EB, and therefore A is equal to, I will write E upon EP, and therefore I will write here E upon A is equal to EP. This is the second statement. This is the first and this is the second statement. That means ratio of emissive power E to the coefficient of absorption small a is the same for all bodies at a given temperature and is equal to emissive power of perfectly black body. Now we are going to see the proof of this. Here you see, we consider here constant temperature enclosure. Suppose this is the constant temperature enclosure. Same thing again, double walled. This is the double walled. We call it as a earth hermanus enclosure. Constant temperature enclosure, and in this we consider two bodies. Suppose this ordinary body, and we consider perfectly black body. This is P body, and we consider this is body O. Now here we consider, suppose B perfectly black body, O ordinary body, A surface area of each body, EB emissive power of body B, E emissive power of body O, small a coefficient of absorption of body O, and small e coefficient of emission of body O. Now you see here, after some time both bodies attains a constant temperature. Now suppose Q be the radiant energy incident on each body per unit time per unit area. Q Q be the radiant energy incident on each body per unit time per unit surface area. I will write here radiant energy incident on each body per unit time per unit area. Now the total radiant energy incident on body O per unit time is QA. QA is energy incident on body O. Out of this energy, this is the total QA with the total energy incident on body O. Then out of this energy, it absorbs A into QA amount of energy. And also it emits E into A. A into QA is this. QA with the total energy incident on the body. Then AQA is energy absorbed by body O. And EA energy emitted by body O. Now that body attains the same temperature, therefore I will write one statement at constant temperature. Energy emitted per unit time. Energy emitted per unit time is equal to energy absorbed per unit time. That means I can write here energy emitted per unit time. That means E into A is equal to A into QA. This A gets cancelled and therefore I write here E upon A is equal to Q. Suppose this is equation number 1. Now the total energy incident on body B is also QA and it absorbs out of this QA. This is a perfectly like body, therefore QA energy absorbed by body B and EB into A energy emitted by body B. And again that body is at constant temperature, therefore I will write same statement here. Energy emitted per unit time is equal to energy absorbed per unit time. That means I will write here energy emitted EB into A is equal to QA. Again this A gets cancelled and therefore I will write here EB is equal to Q. Suppose this is equation number 2. And if we put this equation 2 in equation 1, then we get here, putting equation 2 in equation 1, we get here E upon A is equal to value of Q is EB. And therefore E upon EB is equal to A, or E upon EB means small e is equal to A or A is equal to small e. This is the statement of Kirchhoff's law. This is also statement of Kirchhoff's law. These two are statements of Kirchhoff's law we have proved here. That means coefficient of absorption is equal to coefficient of emission at a given temperature. This is all about Kirchhoff's law. I hope you all understand this. Thank you.